Hello, this video is going to cover AP Chemistry topic 4.5, stoichiometry. So stoichiometry is all about the measurements of how much reactant reacts and how much product is produced. And in any stoichiometric problem, you need a balanced equation, and that's the key here. So for instance, let's say you take some hydrochloric acid, HCl, and you react it with some magnesium. These are not necessarily going to react in a 1-to-1 ratio. So we need to know what the molar ratio is, and that means we need to know what the products are in this reaction so we can balance it. It's a single replacement reaction. Magnesium will replace hydrogen, and magnesium will be bonded to chlorine. Magnesium is 2 positively charged, chlorine is 1 negatively charged, so it's going to take 2 chlorines to make this compound neutral. Magnesium chloride, MgCl2. Hydrogen is going to go off on its lonesome way, and we're going to make hydrogen gas, H2. Remember, hydrogen is diatomic. If you don't remember the diatomic elements, Brinkelhoff is a good way to remember those. Those are the diatomic elements. So if you look at our 2 products here, they do not balance out with our reactants. We have 2 chlorines on the right, but only 1 chlorine on the left. 2 hydrogens on the right, but only 1 hydrogen on the left. So we need to balance it by putting a 2 in front. So here's our balanced equation. This is the essence of stoichiometry. It's the idea that we have moles of reactants producing a certain number of moles of products. Without the balanced equation, we wouldn't know anything about how to predict how much product could be produced in a reaction or how much reactant would be used up in a reaction. So the balanced equation is key. So we're going to do a practice problem with stoichiometry, and just think about how we solve these problems when we're looking at how much reactant will react and how much product will be produced. So our problem is going to be if 22.5 milliliters of 1.5 molar HCl reacts with 13.4 grams of magnesium, what mass of hydrogen will be produced? Remember, hydrogen is diatomic, so H2 will be produced. So we've got a couple of things to think about before we start solving this problem. One is that we're given the amount of reactant and of each reactant. We're given the amount of HCl we have, 22.5 milliliters of 1.5 molar, and we're also given the mass of the other reactant, magnesium. So the question is, do we have an excess of hydrochloric acid, or do we have an excess of magnesium? This is a limiting reactant problem because we have the amounts of both reactants in the problem. What we're solving for, though, is how much H2 could be produced. Now, the amount of H2 that can be produced is going to depend on what we run out of first. Are we going to run out of HCl first, or are we going to run out of magnesium first? So to solve this problem, we're going to have to do it 2 times. We're going to have to solve for how much hydrogen the HCl could produce, and then we're also going to have to solve for how much H2 could be produced from the magnesium. So 2 different problems here. So let's go ahead and start with HCl, how much HCl we have. So we're going to start our first calculation by figuring out how much hydrogen could be produced from the hydrochloric acid. So to do that, we're going to start with the amount of hydrochloric acid we have, which is 22.5 milliliters of HCl. Now, molarity is in moles per liter. So if we're going to convert between liters and moles, we need to have our volume in liters. So I'm going to have to convert our milliliters into liters. Now, of course, you could do this just by moving the decimal. I'm going to go ahead and do this using dimensional analysis. There's 1,000 milliliters in 1 liter of HCl. Then, according to our molarity, for every 1 mole of HCl, 1.5 moles of HCl, you have 1 liter of HCl. So molarity, if you recall, can be used as a conversion factor between liters and moles. So now we've converted between liters and moles using the molarity. So if we start accounting for things, milliliters cancel out, liters cancel out, and we have moles. From the balanced equation, for every 2 moles of HCl that react, 1 mole of H2 will be produced. So 2 moles of HCl react, 1 mole of H2 is produced. Now the problem is asking for mass of H2. So I'm going to do one more step and solve for the mass of H2 that's produced. And from the periodic table, I know that 1 mole of H2 is 2.02 grams of H2. Moles cancel, and we're left with grams. So notice all the units canceled along here, and the whole point of this was to figure out how much H2, how many grams of H2 could be produced from our first reactant, the amount of first reactant. If you do this calculation, you will end up with 0.034 grams of H2. Notice two significant digits, because in our problem, our least significant digits is 2 significant digits. So if the magnesium was unlimited, this is how much hydrogen could be produced from the amount of HCl we have. But we're not unlimited magnesium. We have a certain amount of magnesium. So we've got to solve this problem again, but this time starting with our magnesium. How much H2 could be produced from this much magnesium? So let's go ahead and do that. 13.4 grams of magnesium. How are we going to convert grams into moles? From the periodic table, of course, the molar mass. 24.31 grams of magnesium is 1 mole of magnesium. Remember, the coefficients in front of everything in our balanced equation is all about moles. 2 moles of HCl react with 1 mole of magnesium to produce 1 mole of magnesium chloride and 1 mole of hydrogen. So if we're going to use the balanced equation, we have to get our initial amounts of substances into moles. And that's what we did here. Grams to moles. Okay, so our molar ratio between magnesium and hydrogen is 1 to 1. 1 mole of magnesium produces 1 mole of hydrogen. So that is going to be our next conversion. Moles of magnesium, moles of what we have, to moles of what we want, hydrogen. Moles cancel, grams cancel, and we now have moles of hydrogen. But the problem is asking for grams of hydrogen, so we're going to do one more step and convert from moles of hydrogen to grams using the periodic table. The molar mass of hydrogen is 2.02 grams per mole. So 2.02 grams for every 1 mole of hydrogen. That's our conversion factor. So now we multiply everything in the top, divide by everything in the bottom, and we get 1.1 grams of H2. So if you compare our two values for the mass of hydrogen produced from HCl and the mass of hydrogen produced by the magnesium, the HCl produces a lot less hydrogen than the magnesium will. The least amount of product is the answer. We cannot make 1.1 grams because the HCl will run out before we get to 1.1 grams. The HCl can only make 0.034 grams. Once we get to 0.034 grams, we've run out of HCl. The magnesium could keep going to 1.1 grams, but we've run out of HCl at that point. So this is our answer because this is the amount that is the least amount of product given our two reactants. So that's just a quick example of how stoichiometry works. Stoichiometry is all about the ratios of the reactants to the ratios of the products. If you have any questions and you'd like to go over more, please talk to me. I'd be happy to help you out. Good luck.